Alright, so we are set to find the product or the answer to this multiplication problem. And multiplying decimals is actually no different than multiplying whole numbers, except for the fact that you have to remember to put your decimal point in at the end. So as far as setting this problem up, I'm going to go ahead and set it up as 5, 1, 6, and then 7, 4 off to the right hand side, multiply. You can put your decimal point in there if you want, but you really do not need it until the very end of this problem. So basically, I know I'm going to have two layers down here that I'm going to have to add together to get my product. I'm going to have a layer with 4 times everything, so I have to know my 4's times table. And then I'm going to have a layer with 7 times everything. And I'm actually going to color code our layers so that you can really see how we work through this process. So first, we're going to go ahead and start with 4 times 6. If I don't know my facts, I'm going to have to come over to the side and list out 4, 8, 4 more, 12, 4 more, 16, 4 more, 20, 4 more, 24. And I can keep my list going in case I need it again. But right now I can see that 1, 2, 3, 4, 5, 6. 4 times 6 will give me 24. Carry my 2. 4 times 1 will give me 4, and I add on my 2 to give me 6. Notice I'm keeping everything lined up nice and neat. Keeping my surgery procedure nice and neat is very important as we operate on these numbers. Now I'm doing 4 times 5, and I can see it, 1, 2, 3, 4, 5 of them will give me 20. Alright, before we move on, we have 3 very important things that we need to do because we have now done the first layer of our multiplication problem. So, I like to use the thought of 3's a charm. We're going to make sure that we cross out anything that we carried. So cross out any carries. So I'm going to get rid of this. Second thing down, cross out my used digit. I have used the 4, so that is gone. And lastly, I'm going to put a placeholder in my next layer down here for each crossed out used digit. So when I look up here, I can see I have 1 digit crossed out. I'm going to put 1 placeholder here. You need to slash your 0 to be able to be sure that that's a placeholder. If you don't slash it, some of you like to use a smiley face to hold your place. That is fine too, but you need to do something to differentiate your placeholder from the rest of the problem. Alright, so now we're ready to do our next layer. So our next layer is going to be 7 times this number, 7 times that, and 7 times that. So what I'm going to need to do here is know my 7's. So the 7's are a little trickier. I'm going to come over to the side, and if I have to use my fingers, I will in order to get all the way along my 7's multiplication. So 7 more, 21, 7 more, I'm just counting on my fingers here, 7 more will give me 35, and if I need to go higher than that, I will in a minute. So, our next one is 7 times 6, so 7, 1, 2, 3, 4, 5, I do need one more, 6 will give me 42. So 7 times 6 is 42. I'm going to leave my 2, keeping everything nice and straight and lined up. And I'm going to carry my 40 to make 42 over top the next thing I'm going to do, which will go here. Because I already did 7 times 6. My next thing is here, so I need to carry my 4 to the next thing I'm going to do. 7 times 1 is 7. Add on 4 more will give me 11. So I'm going to leave my 1 and carry my 10 to the next digit. 7 times 5, if I don't know my facts, I can come over and check. 1, 2, 3, 4, 5 is 35, and 1 more makes 36. And again, I've been very careful to make sure that I've kept everything lined up. Now, I've multiplied this digit times everything and this digit times everything, so I have my 2 layers, so I'm ready to add. 4, 8, 1, 8, 3. Now, at this point, my answer looks like 38,184 because there's no decimal point. But the final step in your decimal point problem is to make sure that you do not leave this a whole number, meaning that there's no decimal or there's one at the very end. You go to your original problem and you count how many digits come after a decimal point in the original problem. So you can see here that we have 1, 2, 3 digits after a decimal point in the problem. So we're simply going to move over 3. I call them baskets, putting a number in each basket. So my final answer is in fact 38 wholes and 184 thousandths. Another way of knowing that your decimal point goes here is that you could estimate using the whole number in the original problem. You have 5 wholes times 7 wholes, which gives me 35, which means my final answer should be somewhere close to 35. And 38 is as close as I'm going to get to 35 when I'm placing my decimal point. So there you have finding a product to a decimal multiplication problem. One other thing I want to remind you of is that multiplication is the same backwards and forwards, meaning that I could flip this problem and set it up this way, and it's going to look really weird to you, probably. Now, I could have solved this problem this way because we know that multiplication is commutative, meaning I can change the order and I'll still get the same answer. The reason I don't want to do it this way is because now I'm going to have 3 layers that I add up, because I'm going to have to do 6 times everything, cross out carries, cross out the 6, put my placeholder, 1 times everything, cross out carries, cross out what I used, have 2 placeholders, and so finally I'm going to have had to add up 3 layers to do it this way. So we always want to put not necessarily the biggest or the smallest, but we want to put the one with the least digits on the bottom, because the least digits mean the least number of layers that I have to work through. So on a problem like this, on the other side here, even though they wrote it 3 times 14.5, I could solve it this way and get the right answer. I could even put zeros up here if I wanted to, but really all that's doing is making me do more work, because now I've got to multiply out 3 layers down here in order to get my answer. And it would be much easier and much faster that even though they wrote it this way, to go ahead and flip it around and say, well, I like to do less work, so I'm going to put the 3 on the bottom, because that way I only have to get actually 1 layer for this problem. This problem would go very quickly this way, because all you're doing is 3 times each digit on the top. 3 times 5, 3 times 4 is 12, oops, sorry, 3 times 4 is 12, and 1 more is 13, and then 3 times 1 is 3, and 1 more makes 4. So then I could very easily see in the original problem, there's only 1 digit in this problem that comes after a decimal, so I'm only moving over 1 digit, and my final product would be 43 and 5/10. So just a little bonus thing to think about here is, I know all of you probably like to do the least amount of work as possible, and so keep that in mind when you're stacking your problem to multiply. And other than that, you just want to make sure you remember that 3 is a charm. There's always 3 things to do before you move on to your next layer.